I'm just going to talk you through the questions on atom models on page 7. So I have the questions over here. And question 1 is just to complete the diagram, which is very similar to the worksheet that you did on page 5. So alpha particles, so here's the nucleus of the atom. So the alpha particles that are far away from the nucleus will continue on the same straight line. If they come relatively close, they're going to get deflected, and if they actually hit the nucleus, that's when they get reflected. Okay, question 2. If the particles, so there's a diagram with a whole lot of alpha particles or particles that is coming towards the gold nucleus, but we've got to say what are the possible paths if the particles were positive, negative, or neutral. So if they were positive, they'll be repelled. So it's your B, C, and E. If the particles were negative, if the charge on the particle is negative, then it's going to get attracted, so that'll be A, so it's going to kind of go behind the nucleus. And if it's neutral, nothing's going to happen, so the answer is D. Okay, question 3. So just label all the particles that make up the atom. So the negative charges are the electrons, these are your protons, the other ones are your neutrons, and the whole thing here is your nucleus. Okay, then the next one here. So this is the observations that Rutherford made. So the first one was if the particles, he noticed that all of the alpha particles, most of them went straight through, almost all of them went straight through without deflection. That means they did not encounter anything in the path. And the conclusion was most of the atom is empty space, and you can also say whatever makes up the atom occupies a very small space. Okay, and then the next one is a few of the particles were deflected from the original path, and that's because of the force of repulsion, and because it's between charged particles, we call it electrostatic repulsion. That means that the alpha particles would have come close enough to something of a similar charge. So the obstacles in the path of the alpha particles would also be positively charged. So that's why he came up with his conclusion to say that the nucleus is positively charged, and these positively charged particles, he named them protons. Now, and then he also noticed a very few were reflected backwards. That's because and the gold foil itself did not move. That means that the nucleus of the gold atom is much more massive and dense compared to the alpha particles, and also because the nucleus is positively charged and the alpha particle is also positively charged. So as the alpha particle gets closer and closer to the nucleus, the force of repulsion would be so great and that it repelled it so much that they went backwards. And then finally, it's about Thomson's model. Explain how the discovery of atoms can be made, discovery that atoms can be made to emit negatively charged particles, which are your electrons, allowed Thomson to develop his model. So just remember, before Thomson, we had Dalton, who just said the atoms were spheres and there's nothing smaller than the atom. So Thomson discovered the electron, and he found that the electrons are negatively charged, and so he knew that the atom was electrically neutral. So he said that the atom had an equal amount of positive charge to balance out the negative electrons so that the atom's neutral. At that time, they did not know about the protons or neutrons or the nucleus, so in your answer you should not use any of these words when you're talking about Thomson. Okay, all that came later, and I hope this makes sense, and I will